All right. So 1.4 talks about angles, okay? And really what we're going to do is go through, we spent about 3 days talking about segments, okay? Identifying them, labeling them, seeing some characteristics and relationships. We measured them. We did postulate work with them, with adding them together. Now we're going to go through the same exact 3 days, but in regards to angles, okay? And then once we have information about angles, we have the 2 tools that we need to really develop the rest of geometry. We have the ability to measure distance, and we have the ability to measure angles, and that creates basically the rest of geometry for us. Okay? So we talk about angles thing. And really we're just going to identify what an angle is, okay? Maybe how we label them, how we name them, classify them, that kind of stuff, and then probably next week really do some work with them. An angle, by definition, is the figure formed by 2 rays that share the same endpoint or have a common endpoint. We call that common endpoint, or that endpoint that they are sharing, we call it the vertex. And we refer to the rays of the angle, we just generally call those sides. You don't need to draw that picture, but I'm just trying to explain the purpose of our definitions. Remember, definitions classify things for us, they group things, categorize, identify things for us, which is nice because then, especially in this class, because after I identify an angle, we start talking about an angle, there's going to be procedures that we can do with angles. There's going to be things like measuring them. There's going to be things like angle addition. There's going to be things like bisecting, all that kind of stuff. Okay? And I want to investigate all angles that I come across by applying those procedures to them. Okay? So at some point this year, I'm going to give you this picture here. We're going to start talking about circles and all the segments and lines that intersect circles. And eventually, we're going to talk about looking at just that right there. Okay? And every year somebody wants to figure out what is the measurement of that. Okay? They want to throw a protractor up there, or they want to do something weird with maybe angle addition or something like that with that thing right there, finding that measurement. And my question to you is, can I do that? No, why not? Absolutely. Okay? So an angle, by definition, is formed by 2 rays. So by the definition, it kicks that thing out. It says you cannot do the angle stuff with that thing because it hasn't met the requirements of being an angle yet. Does that make sense, everyone? All right? And that's the purpose of our definition, because we want to start doing certain procedures with certain shapes and certain objects. And if something doesn't meet that criteria, then I can't do those things with it. Okay? For instance, we measure segments, right? Those are the only things right now that we can measure, okay, with a distance. So if I ever ask you what's the distance of an angle, you got to look at me and say you can't do that, okay? Because an angle doesn't meet the definition of a segment, and then I can't do the segment stuff with that. Is that all right with everybody? All right. We do measure angles, but it's a little bit different than how we measure segments. When we name angles, okay? Obviously, we don't want to write the word angle out a lot, okay, because we're kind of lazy, I guess, in regards to writing things. We want a little bit of shorthand in regards to our math. I'm going to give you, I think, 3 or 4 ways here to name any angle you come across, okay? But I'm going to kind of give you the approaches in the safest kind of hierarchy. So the first way I show this is going to be the safest way you can name an angle, and it will never fail you. Okay. The last way I show you will be the kind of the riskiest way of naming an angle. Okay, and I'll kind of explain those things as we go through. Just like other shapes so far, like segments, or lines or rays, the way I name an angle should provide me kind of a roadmap for being able to trace that shape out with my hand. Okay? So if I were to want to trace out that angle, okay, I'm going to say that I should probably start at point B or point C. Okay? So that's what we're going to do. We're going to start at point B. Okay? Now put yourself on that and your finger on B. Now if you wanted to trace that angle out, where would you go next? Where's the most logical place to go? What point? A, right? And when I say I want to trace these things out, I don't want to kind of backtrack at all. I never want to trace something out and then go back over top of it. Okay? So we'll start at B, we'll go to A, and then where would I finish to trace out that angle? C. So I name it BAC. Okay? But if I name it that way, and that's all I do, remember what we talked about earlier in the week, I am now talking about a plane. So go back to how we define planes and talk about how we label those. We use 3 capital letters, right? So I want to make sure that I'm not talking about a plane, I'm not talking about an angle. So what we always do is we put the angle symbol out front. Okay? Sometimes people like to put that little thing there. But now I know we're talking about an angle. And if I put my finger on B, A, and C, it traces out exactly that black angle. Okay? Now my question to you is there a different way I could do that using the same 3 letters? C-A-B. Start at C, go to A, go to B, right? Traces out the exact same thing. So I can kind of reverse the order for my angles. Again, sometimes that's a problem because I might be saying in class in a homework question or something like that, I may be referring to an angle BAC, but you always called it CAB. All right? We just got to be able to make that link, make that connection. You notice that each time I named it, the vertex has to be the middle point. Okay? If the vertex is not the middle point, then I'm never going to trace out that angle. For instance, if I just say, I have to use ABC, right? Those letters. If I use them in the order ABC, let's see here. Remember, it's a map for showing me the directions for tracing this thing out. If I go ABC, I want to trace out that blue angle, and that's not the black one, right? And that's something that people do all the time. It's the biggest mistake with angles and naming them, is that people forget that there's structure to the name, okay? And that order is important. So you can't just say, these are my 3 points and put them in any order I want to, okay? The vertex has to be the middle point, and then if you've got that, then really B or C could become first or last, all right? Again, another issue that occurs, and what if I've got another point on here? If I call it angle EAC, is that the same angle as BAC? Trace out the same thing? Yeah, because what we're understanding is that when I trace out those sides, they're rays and they should go on forever. So they should pass through E forever, just like it passes through B forever. So little things like that might, at first, be a little confusing for us, but we'll pick up on that and won't be too bad. The next way we can do it is through the use of a numeral, okay? They might put a number down there to identify this so we can talk about it easily or quickly, or reference it easily or quickly. So I just call that angle 3, okay? Now there's no degree symbol. If there's a degree symbol there, that's talking about a measurement, and you would not use that, okay? But if it's just a numeral, you can name it by angle 3, okay? That's a little bit risky, okay? But the riskiest way of naming an angle, and this is perfectly fine because this is a kind of a solitary angle. It's all by itself. I can call it just angle A, okay? And people like to do that because if I had the option of writing 3 letters down or 1 letter, I'm going to write 1 letter, right? Okay, it's easier, it's quicker, it's more efficient, okay? But it's risky. And the reason it's risky is because a lot of times when we're dealing with angles in this class, they're not by themselves, okay? And what I mean by that, if I show you this picture, Okay? If I show you that picture, I say everybody look at angle A. How many different angles up there have A as a vertex? 3. Okay? We have that one there, right? Okay? The other one everybody probably sees is that one. So everybody hopefully said 2 at least. Okay? But when I add those together, don't I get that third angle there? That kind of makes sense? And we use those arcs to kind of draw our attention a lot of times to one of those angles instead of tracing back over the sides. So if I wanted everybody to look at the red one, the best way of doing that is to say DAB, angle DAB. Now everybody's focused on the red one, right? If I say, it's kind of the idea if we had 3 Lexes in this class, I say everybody look at Lex, we got eyes going everywhere, right? If I say everybody look at Lex Bodecker, we're all looking right here, correct? Okay? So that's kind of the approach that we use here with naming angles. Again, I could name it with numbers, it might be a little bit easier. Maybe angle 1 and 2 there. But if I want you all to look at the sum of those, if I want you to look at angle DAC, there's really nowhere for me to put like a numeral of 3 in that picture to really make it hit home on the fact that I want angle DAC to be called angle 3. Does that make sense? Okay. So if I want to talk about that sum of angle 1 and angle 2, I would just still use the 3 letters DAC. Okay. If you question whether is it okay to do it this way, don't do it that way. Name it with 3 letters. Okay. Safest thing to do is naming your angle with 3 letters. Okay. If there's ever a question, you probably don't want to do it the way you're thinking you want to. Is that all right with everyone? All right. Let's see here. When we talk, this will be the last slide. When we talk about angles, there's some locations that we need to talk about for some of our theorems and definitions and postulates, and it's the points that all of our angles kind of create. Whenever we're talking, you guys, in this class, everything that we do should really be in kind of some type of coordinate system, whether it be a 2-dimensional or a 3-dimensional. A lot of times we don't draw it. We don't draw the XY axes and that kind of stuff, but they're hidden there, okay? And what that allows us to realize then is that, there's a point right there, correct? There's a point right there. There's a point right there. There's a lot of points there, isn't there? Okay, inside that angle, there's a lot of points. So I'm going to highlight those blue in here. In those blue points, every point on the inside of those 2 rays, okay, is the interior of my angle. And when I say the interior of my angle, I'm talking about all of those points that are on the interior. Okay? If I have an interior, chances are I probably have a exterior as well. So all of these green points are my exterior points. Okay? And all shapes are going to have these. Okay? Draw a circle on a 2-dimensional plane. There are points that are on the inside of the circle and there's points on the outside of the circle, right? Do the same thing with a square, do the same thing with a triangle. All those things have interiors and exteriors, but they also have other points. Because point B, think about point B or A or C or any other point that might kind of model or resemble A, B, or C. Are those points on the interior? Is B on the interior? Or is B on the exterior? Or is it on the border? Is it on the boundary? Does it kind of make sense? B is on the angle. So that's the third grouping of points that an angle develops in our plane. You got points on the interior, you got points on the exterior, and then you have points on the shape. Okay? And points that are on the shape are neither the interior nor the exterior. And that's something to think about. Because you're going to see this probably the next time we talk about notes. We'll introduce a postulate that says you're going to choose a point on the interior of angle BAC. Well, then that narrows my focus down to the blue stuff. Okay. There's no new homework tonight that is due tomorrow. There are a couple assignments that I've opened up, but they're not due until next Wednesday. All right. I emailed you about them. Make sure you read your email before you get to school tomorrow. I would read that tonight. Give yourself a little bit of time. Don't do it right before bed because you might want to do something prior to falling asleep tonight in preparation for tomorrow's class. Okay? But make sure you're reading your emails. But I sent out one today, said that I assigned an algebra review. Did I talk about this at the beginning of class? No. Okay, so I assigned an algebra review for chapter 1. So I went through all of chapter 1 and said, okay, what is the kind of the predominant amount of algebra that we're doing in chapter 1? And I created an algebra review on Math Excel for you to do. It's due next Wednesday at 11:59 p.m. It's got view an example, it's got help me solve this, all that kind of stuff. It's a refresher crash course for you to get better at that algebra so we can address the geometry a little bit more, okay, in a better way. I'll do that for every chapter or every group of chapters. So chapters 2 and 3 share a similar type of algebra. So that assignment at the beginning of chapter 2 will be for both chapters, okay? We'll use some system equations, that kind of stuff. I've also sent you out an email that has a Word document in it, okay? And it's a worksheet. You can print that off or use it off your computer, whatever. But you got to complete that worksheet by next Wednesday. It's over sections 1, 2, and 1, 3. Shouldn't be anything that's kind of mind-bending or anything like that. It's really not that difficult. But you're going to do that worksheet, and then you're going to go to Math Excel, and you're going to open up the assignment that says 1.3 worksheet, and then in parentheses it says not a quiz. In Math Excel, it's going to show up as a quiz, because I don't want you to have similar exercises. I don't want you to know what the answers are when you submit it, okay? Because I don't want Lex to submit it tonight and then go show Canyon all the answers tomorrow and he gets 100, right? Because that happens, okay? So you won't be able to see your answers until next Wednesday, but you will know immediately what you got on that worksheet. Next Wednesday, it's due 11:59 p.m., so Thursday morning next week, I'll make a video or I'll post a video of me going over every single question in that worksheet. Because I don't think it's a good idea to waste an entire day going over that worksheet. If, say, Lex got every one of them right, I've wasted a day for Lex, right? Okay? Let's say somebody only missed 2. They can go through and they can find the 2 that they missed. They can watch those in maybe 30, 45 seconds and then be done with that review. Does that make sense? Okay? So a lot of times with worksheets, tests, quizzes, I don't spend time going over them in review together in class, but I'll make videos and I'll post those so that you can individually go look at them, all right? Last class I told, think about it, if we review for a test, we take a test, and we review the day after a test, and we have 13 tests, that's 39 days of school that we've wasted reviewing. 39 hours of class, right? Does that kind of make sense? So I don't like to do those things, so I think there's a lot of information that we could spend that time on and use it a little bit more wisely. So that, but you have to take the initiative outside class if you're missing something to go look at those resources. All right. So that's all I've got for you today. Obviously, bell's going to ring here pretty soon. Have a great rest of the evening. And tomorrow it's supposed to be cooler.